Okay, well now we're going to talk about function inverses, and we'll do a definition and an example and then a short theorem. Okay, the definition of inverse functions. Basically, before we get to it, informally, if two functions, an example of two functions that would be inverse functions, if the first function takes in a number and multiplies it by 3, and then another function takes that result and divides it by 3, you end up right back where you were. Those would be inverse functions, multiplying by 3, dividing by 3. So they kind of, one of them will undo the other one, and it doesn't matter which order you do it in. If you take a number and divide it by 3 and then multiply it by 3, it also gets you back to that same number. So that was a real simple example of a pair of inverse functions. So in general, if f, which goes from a into b, and this is very important, and g goes from b into a, are such that the following is true: g of f of x equals x for all x in, and I'll fill this blank in a minute, and f of g of x is equal to x for all x in blank, then f and g are inverse functions of each other. So I just want you to think about what set this x comes from and what set that x comes from. Well, it's easy if you think about how this composition of functions, remember this is g composed with f. The first thing you have to do is the inside. You have to do f of x before you apply g. So x has to be plugged into f. So what numbers can be plugged into f? The domain of f. So this x has to be in the domain of f. And likewise, g of x, if it's done first, if you're plugging a number into there, well, b is the domain. So that needs to be for all x in b. Then f and g are inverses of each other. So let me draw a real simple picture. If we have the set A and the set B, I purposely made them different sizes. If f takes numbers from A into B, then the inverse function goes the other direction. This would be my g if f and g were inverse functions. F inverse starts in the range of f and comes back to the domain of b. So the domain of f inverse is the range of f, and vice versa. So anytime you have two inverse functions, the domain of one is the range of the other. The range of one is the domain of the other. They go back and forth like that. And in this case, in this definition, we could say f inverse is equal to g. But also, f is the inverse of g. You could say that f is equal to g inverse. Whichever one you like better, you can call the main function, and the other one is the inverse. All right, well, you may remember how to figure out, or how to compute an inverse function from maybe pre-calculus or some algebra class you had. Let's just review the 4 steps, little 4-step procedure. Very simple. And notice I didn't list the domain and range of this function. The domain and range are both all real numbers. So the inverse will also have a domain and range of all real numbers. So to find f inverse, there are 4 steps. The first one is real simple. Just replace, I'm not writing out the recipe, I'll let you do that. Step 1 is just replace f of x with the letter y. And then step 2, the recipe would be to interchange x and y. If there's more than one x over here, you change all of the x's into y's, and you change this one y into an x. So x equals 3y minus 7. 3 is the only one that uses any math at all. Solve for y. So I'm going to add 7 to both sides. And one more line to get y by itself. I would say y is, dividing by 3, x plus 7 over 3. And then step 4, again, another no-brainer. Just replace y with f inverse of x. So we found it. If this is your given function of f, your given function f, this is f inverse. And it kind of makes sense. Notice you're multiplying something by 3 here. Here you're dividing by a 3. Here you got a minus 7. There you got a plus 7. So it would be good practice to do this. Again, only start with this function. If I said find the inverse of g of x equals x plus 7 over 3, what do you think you're going to come up with? Well, repeat this process. You're going to get g inverse of x is equal to 3x minus 7. So if they're inverse functions, if you start with one and do the recipe, you're going to get back to the other one. And I'll just make the same comment. The domain and range of this one are also all real numbers. Obviously, this one takes reals into reals. This one goes backwards, and it takes the reals into the reals as well. All right, so I'm going to state and not prove two very, very short theorems. I will maybe write it down as theorem A, just a statement A and statement B, like maybe just one theorem. You make that capital. Function f is invertible, which means it has an inverse. If and only if IFF is if and only if it is bijective. F is bijective. So that means 1 to 1 and on 2. And theorem, the B part of that, says that if f is bijective, well, we know if it's bijective, it has an inverse. If f is bijective, then so is f inverse. So if f is bijective, f inverse is bijective. And f inverse is unique. So an invertible function has one and only one inverse. And I'm going to put one more little comment in here. And f inverse equals f. That makes perfect sense. This is just like saying that if f and g are inverses, then f is g inverse and g is f inverse. So if you take the inverse of f inverse, you get f.